Welcome to Crystal Clear Education Center. Here, learning made simple. We are in our third video, tips and tricks to solve series and parallel. You can see combination of resistor here, and I think it's looking a little complicated. It's all our mindset. Let us make it very clear with small tips and tricks. And actually, it is very easy to find out what type of combination it is, whether it is a series or parallel. This is chapter electricity, class 10. Before going into the lesson, today's quotation, all you need is the plan, the roadmap, and the courage to press on to your destination. So let us kickstart. Before going into the numericals, in general, what is a combination of resistance and how hard the combination will be? Okay, so combination of a resistor. So in this combination, we'll have two things. One is the combination where you'll have a parallel, okay, which is having 1 point, okay, where the current is going to divide here. Already in my previous video, I told you how that is getting divided. So the current going to divide and then it is going to pass as one. This is one, we call it as parallel. Okay, another one, it is going in a line, series. Okay, so this is series and this is parallel. Okay, so how are these things going to be connected in a combination? We actually solve this one in the resistor, like separately in series and parallel. Here we are going to see the combination of resistance. Suppose if I'm going to have a resistor like this. Okay, from here it is getting divided. Another two resistor I'm connecting like this. Okay, and then here. So this is point A and this is point B. So let me connect it with the battery too. Okay, and let me have an ammeter and let me connect it. Okay, so the ammeter reading, as we all know, it has to be connected positive terminal of the battery. And here, this is some voltage, okay, voltmeter, we know how to see now. Let us see only about the combination of the resistor. And later I will tell you about the voltage differences and how to find that. So now the resistors are connected in two different, one in series, another one in parallel. So suppose if it is 2 ohm and this is 2 ohm and this is also 2 ohm. Okay, three 2 ohm resistors we have connected in a combination as one parallel connection, one series connection. So we have to find the resistor in parallel first. Okay, for these two things. Okay, this is parallel. The parallel formula 1 by Rp is equal to 1 by R1 plus 1 by R2. If you want, you can name this as R1, R2, R3. Okay, which is nothing but 1 by Rp is equal to 1 by R2 plus 1 by R3. So if you see, it is 2 by 2, which is nothing but 1. Okay. And R1 is in series with Rp in series now. Okay, actually the parallel, we have made it into a one equivalent resistance. Okay, one equivalent resistance, which is nothing but the parallel has turned into a equivalent resistance. And when you add this R1 with Rp, you will get 2 plus 1, 3 ohm. Okay, so this is the way we are going to find the equivalent resistance of the combination resistor. So this is one area. The same three resistors I can connect in another way also. I can connect like a series. Just I'm telling you how to have different combination. This is only one series or another combination if you take it like this. Okay, by this you can guess what type of resistor it is. Okay, this is parallel. Now this is a combination. This is the one, this is one type of combination. Another type of combination, this is one I've kept a series, two parallel. Okay. And now I'm going to keep the other way like this. Just observe and find the combination. Yeah, got it. This is point A and this is point B. So it is connected in this manner. So two series, another one parallel, but both are in parallel like this. This is one type of combination. Okay. And this is one type of combination. And this is one type of combination. So let me number 1, 2, 3, 4. In 4 different way, I can have the combination of resistor. Okay. Either purely series, okay, or purely parallel, or with the combination of parallel and series, the same here. Okay. So we'll move on to the question, and it will be very easy for you when we switch over to the question and solving it. So first, identify the series combination in the following figure. So in this, which is series, before finding the series, we have to check for the point. The point here, you can see from here to here, is there any break or junction? Anything is coming and attaching any wire, we are giving a connection here that we need to check. So from here, if you go in a free manner, it moves. So it is in series. Okay. And whereas here, if you see, this is having a junction here. Okay. It is having a junction. So it is not a completely series. It is having some parallel connection. So the question is, identify the series combination. So this will not come. This is a series. Next, we are going to check this one. Okay. In this, if you see, the current is dividing. Okay. When it is dividing, it is not in a series. It should go in one way, like unidirectional way, it has to move. So it is going in this way. This is series. But here, if you see, it is dividing like this. So it cannot be in series. It is having a parallel connection. If suppose if you want to redraw, you can see like this, it goes as 2. And this is in series. This one and this one in series. So that let me draw like this. Okay, another one like this. And the diagram I've redrawn, and you can see the parallel connection here. That is why I said it is not in series. Next, observe, you have to always start from the point where it is. From A, if you move 1 and then 2 and then 3, there is a continuity. There is no junction. Nothing is added. The current is not divided. Actually, it is folded. You can see the route, the pathway. It comes like this and it goes this way. It goes this way and another way like this. So if you see this, it is only one direction. This is in series. Okay. So I think it's very clear now. We'll move on to the next one. 5 resistors are connected in a circuit. Now it is 5. Okay, so far we were talked about 3. Now it is 5. They are connected in a circuit as shown. You have to find the ammeter reading when circuit is closed. It looks like a triangle, somewhere in between it is joined. In a very simple way, we are going to solve this one. So let me see in what way it is. Let me use white color. Yeah. Always we have to redraw the circuit diagram, like in what way they are connected. This is point A. The point A, if you see, it is, okay, it is in a line. The junction is joining here. We will join this joint later. Okay, so let me take the route alone. So this is one route. It is going this way. Okay. And then see here also it is a bent only, down, no joint here. Okay, then 1, 2, 3 we are connected. Then next, if you see, it comes the other way. Okay, 1, 2, 3, 4. Actually 5 resistors. And the 5th resistor, how they have connected? It has connected here between. So I'm using another color so it will be very clear for you. Here is a joint. Here is a joint, okay? And it is connected between these two. That's all. So this is point A to E. A to you need not write B, C, D and all. Okay, A to you. And this B and D is only connected like this as a joint. You have to redraw this way. Okay. So just see the path A, B like this. It goes 1, 2, 3, 4. And this BD is joined between these two. Okay, these two resistors. So that's it. So now we will write the value, the resistance 0.5, 3 ohm, 3 ohm, okay, 0.5 ohm. And here it is 3 ohm resistance. Okay. So now we are going to find the equivalent resistance. Now first let me find the resistance of this, because this area, let me highlight and show you this area. Okay, this area we are going to find the value, and then that will be attached in series. So that part, okay, this if you want you can number as R1, R2, R3, R4, R5. Okay, now R1, R2 in series. So resistance in series R2 plus R3, not R1, R1, R2, R3, R4, all in series only. But this R5 is connected parallel to R2 and R3. So R2 and R3, first let me find the value. 3 plus 3, 6. And this one, R5, 1 by R5 is equal to 1 by 3 ohm. Now this both are in parallel. So 1 by Rp is equal to 1 by Rs plus 1 by R5. That is nothing but 1 by 6, this number, okay? And then this plus 1 by 3, okay? Which is nothing but, if you take LCM 3 into 2, 2. So 1 plus 2 by 6, which is nothing but 3 by 6. Now, children, you will do mistake when you are doing this in the exam, like casually you leave just like that. Please don't do it. This is nothing but 1 by Rp. Let me write here. 1 by Rp is equal to 3 by 6. We are not finding 1 by Rp. What is Rp only? Resistors in parallel. So it will become inverse 6 by 3, which is nothing but 2. So this is 2 ohm. Now, how it will be connected? The equivalent resistance is R1 plus Rp plus R4. We found value for this. And this in which way they have connected? In a series way it has connected. So we are adding it together. R1, this whole is nothing but Rp, then R4. So what is R1? 0.5. What is Rp? Just now we found it is 2 ohm. Okay, plus what is R4? 0.5. So totally we are getting 0.5 plus 0.5, 1, 1 plus 2, 3, 3 ohm. This is equivalent resistance. The question is find the ammeter reading. Ammeter is nothing but current reading. So by which one? Ohm's law, I is equal to V by R. So here the voltage, okay, the voltage is 3 volt. It is given. So here I'll write here 3 by, what is the resistance? 3. And very simple, the answer is 1 ampere. Okay, see how simple it is. The diagram looks a bit complicated, but if you know that it's alone, you have to check for the continuity, how the flow, and then the junction where it has joined, that's it. You can solve anything just like that. We'll move on to the next one. Okay, so as we have solved the previous one, this is the very simple. And here the voltage will have 3 volt. Okay, so now what is the question? Find the, okay, you have to find the current we are going to find, and 4 resistors are here. So first, this one, how it is connected. Okay, we are going to check this one. It is dividing. You see here it is dividing. Let me use this color. Here the flow is dividing like this. So you are dividing like this. And if you see here, it is a bend. So draw this one. Okay, you are making it straight and you are redrawing this. The same way here, you are making it straight. This is also a bend. Okay, and then you are redrawing this. Okay, and this is not a line and all. Okay, just they are drawing and keeping to make it separate. That's it. So this is the way it has connected. So here 10 ohm, here 10 ohm, here 10 ohm, here 10 ohm, and they are parallel, right? So now the equivalent resistance, okay, 1 by R equivalent, okay, which is nothing but this 1 by 10 plus 10. I'm writing directly because it is in series 10 plus 10. If you write R1, R2, R3, R4, okay, we are writing it in series first. Okay, so we add together 10 plus 10, 20 by 1 by 10 plus 10. Okay, this one R3, R4. If you want, you can write 1 by R is equal to 1 by R1 plus R2 plus 1 by R3 plus R4. Okay, just instead of making a very bigger step, we will make it short. 1 by 20 plus 1 by 20. 2 by 20. This is 1 by RP. Okay, the equivalent resistance. Okay, so what is RP? 20 by 2, which is nothing but 10. It is a 10 ohm. And you have to find the current. Okay, so I is equal to V by R. What is the voltage? 3. It is given here 3 voltage by 10. Okay, which is nothing but 0.3. 3 by 10, 0.3. Okay, 2 by 10, 0.2. That's it. So the current value is this. Simple? Yes. Next, show how would you connect 3 resistors, each of resistance 6 ohm. Each of resistance 6 ohm means R1 is equal to 6 ohm, R2 is equal to 6 ohm, R3, sorry, I'll erase this, R3, okay. Yeah, R3 is equal to 6 ohm. So 3 resistors, each of resistance 6 ohm. Okay, you have to show how we are going to connect so that the combination, so understand the word combination, so it is series plus parallel, has a resistance of 9 ohm and 4 ohm. The resistance answer they are given the answer, they are given the R value. You need to find how it is connected. That's it. Okay, no current, no voltage, only the resistor, how they are connected. So first, to get 9 ohm resistance, how it has to be connected. Now, you know this two combination, right? One totally in series, another one in parallel for beginners. Okay, how you have to think. Yeah, I'm just connecting and showing. Okay, if this is the case, 6 plus 6 plus 6, how much it is? 6 threes are. Okay, the value will be higher. Okay, 12, okay, so 18, totally 18 ohm you're getting, you will not get a, or there is no 18. So ruled out, we cannot use it. Now, if you do all these things like 1 by 6 plus 1 by 6 plus 1 by 6, so it is becoming 3 by 6. Okay, if you do like this, the least resistance you will get it. So this is also not true. 2 ohm will be the answer. This is also ruled out. Okay, these two you cannot do. You need to do a combination. So don't think always to connect only in one way. You need not try also actually, because they are given in the question combination. Okay, it is not the purely parallel or a purely series. It should be in a combination. So how it can be in a combination? So in the first figure I showed you, you can do this way. It is how many resistor? 3 resistor it is. So one, I'm going to have a series. Another one, I'm going to divide it. Okay, like this, I'm going to connect R1, R2, R3. Okay, this is one. If you want, you can complete with a circuit diagram, like with a battery, Okay, you can have an ammeter. Okay, close it. Okay, positive to negative, and here negative, positive, ammeter. Positive, negative. This is one. Then here I have to check whether I'm getting 9. Okay, first let me check this one. Then I'll try for the other one. So R1, R2, R3. This first I want to find in parallel. 1 by Rp is equal to 1 by R2 plus 1 by R3. So all same value only 6. So 1 by 6 plus 1 by 6. You'll get 2 by 6. This is 1 by Rp. So I'm going to change Rp is equal to 6 by 2. Okay. So it is 3. R we got Rp is equal to 3 ohm. Therefore, equivalent resistance equal to R1 plus Rp. This one, okay, I'll use another color. So be very clear for you. This one is in series. Okay, actually we got a value for this, and that is connected in series with R1. And that is why we are writing this formula. Okay, so which is nothing but, what is R1 value? 6. 6 plus 3, how much? 9. That's it. So we got it. So next, to get 4 ohm, how it has to be connected. So this is one. We cannot connect in series or parallel. It has to be in combination. One combination, one alone I kept series. In another combination, I'm going to keep both in series, and this I'm going to connect it with parallel. Okay, like this. I'm going to connect with a parallel. Either you keep it inside or you keep it outside. It doesn't matter. Ammeter reading. So again, positive, negative, negative, positive, ammeter. Okay, yeah. So you can keep this as R1, R2, R3. So added resistor in series equal to R1 plus R2. What is R1? 6. 6 plus 6, 12. 12 ohm. So Rp, 1 by Rp is what? Okay, that we are going to check. Actually, this Rs is totally in parallel, okay, in parallel with R3. So 1 by Rp is equal to 1 by Rs plus 1 by, this is S, okay, 1 by R3, which is nothing but 1 by 12 plus 1 by 6. Okay, let me erase this, or I'll use another color and I will write this side. So 1 by 6, let me take LCM, 2, okay. So 2 plus 1, 3, 3 by 12, okay. And which is nothing but Rp is equal to, okay, 12 by 3, which is nothing but 4. So that is equal to 4 ohm. Okay, we got the answer 4 ohm. Okay, let me write it separately. This 4 ohm. So Rp, our equivalent resistance equal to 4 ohm. We got this. We got this. Okay, for this. Yeah. Yes. So I think we made it very simple. We'll meet you later in another video shortly. Thank you.